Welcome back to Mr. Powers Teaches Math. We're still messing around with probability, and I just talked about your basic what probability is. Number of ways to get what we want over the total number of possible outcomes, or if we're talking about experimental probabilities, the number of times we got what we want out of the total number of trials, total number of experiments, total number of outcomes that occurred, right? So it's not that different. It's always pretty much kind of like what we want out of the total. And we also talked about probabilities can only go from 0 to 1. So here, let's do an example. We got a fair six-sided die. That's your normal dice. Has a numbered sides numbered 1 to 6. Christian rolled the die 45 times. 45 times. He rolled a 2 7 times. Okay. Find both the experimental and theoretical probability that the die lands showing a 2. All right. Well, that's easy. So let's do the experimental first. The experimental probability is really, really easy. It's theoretical stuff that's a little bit more tricky. So he rolled a die 45 times. So there's your total. There's your total number of trials or experiments or outcomes. So the experimental here, 45 goes down there. He rolled a 2 7 times. So there were 7 times he got what he wanted. All right, so there's our experimental probability, 7 out of 45. Theoretical probability, and that's a different thing, right? Theoretical probability was, well, how many total outcomes are there each time we roll the dice? There's 6. We got 6 sides. How many ways are there to get what we want? Well, we want a 2. We only want 2s, and there's only 1 2 out of the 6 sides. So there's only 1 2. So I wrote, no. So there's 1. So each time we roll it, there's 1 outcome that we'd like to get out of 6. So there's our theoretical probability, 1 out of 6, and our experimental probability would be 7 out of 45. And it's as simple as that. Nothing more to it. So, something we could do just for fun, and I think I will, is we can take a look at a calculator and see how close those are. Are those close? Are those a little different? Let's take a look. All right, so let's take a look at this. Our experimental probability was 7 out of 45. So 7/45, 7 out of 45, bam. 0.1555555 or 7 out of 45. Okay. And then what is our experimental probability is 1 out of 6. Pretty close, but not exact. And that's the thing with experimental probability. It often, if not always, pretty close to always, often is going to be a little different. But, of course, the more we do it, the closer we get. And I made that point before. So this, yeah. So experimentally, this seems reasonable that this might happen. Now, maybe for fun, what if it was, we wanted it a little higher? What's 8 out of 45? What if we got 8 2s? Just for fun. Actually, now that's very interesting. 8 would have been too many. So out of 45 trials, we actually got as close as we could get to the experimental probability here. Right? So there is that also. 6 or 45 is not a multiple of 6. So no matter what, we're going to get a little difference there. All right. So that'll do it for this video. Until next time, enjoy doing math.